Hi there. It's a really good idea before you finish these review problems to check with this video to make sure on each question you have started off by defining the parameter correctly, by stating the hypotheses correctly, and you know what test to use. So here, the parameter is the population mean difference. So literally, we're interested in the real mean difference between the amount of E. coli detected by these two different methods. So understand there are a total of 10 observations within this sample. The sample size is 10. So for every sample of beef, we have used method A and method B in order to determine how much E. coli may be present within that amount of beef. So the difference between those two values detected by method A and method B, there are going to be 10 of those differences. And we are interested then in the mean of those differences. So the idea here is, in terms of your calculator, to proceed with the test, I would probably put the values from method A, I would put those into list 1. I'd put the values from method B, I'd put those into list 2, and then I would take the difference between list 1 and list 2, that would be A minus B, and I would store that into list 3. Then you can use the data option in your t-test command, and you can run your test based on the data that you've stored into list 3. So this is a test about a population mean difference. So if there is no difference between these two methods, we would look at a null hypothesis value where the population parameter is 0. The alternative is not equal to 0 because we're being asked, is there a significant difference in the mean amount? We're not being given a direction in which we would expect that difference to be. So we're just looking for a significant difference or no difference. So this is a double-sided or a two-tailed test. The alternative hypothesis is not equal to. So this is a one sample t-test. We have one sample of 10 differences, and it's a t-test because this is a test involving means. So for the question on the back, this one's a little bit more straightforward. This question doesn't say the word mean anywhere within it. This is all about a proportion. So P is the population proportion of boxes of this type of cereal that actually contain a voucher for a free video rental. So this is a test involving a proportion, and if you read the question carefully, so based on the experiences of these students, they are interested in looking for evidence that the actual proportion of boxes that contain vouchers may be less than what is stated by the company, less than 0.2. So that gives me an idea of what the alternative hypothesis should be. Sometimes it's easier to write the alternative hypothesis and then go back and write the null hypothesis. We're interested in finding evidence that P is less than 0.2, so the null hypothesis has to be an equation, so we want P equal to that 0.2. It's important that the null hypothesis is equal to one specific value because indeed to find the P value, we're going to assume this null hypothesis is true, and the calculator command uses that one null hypothesis value to actually calculate the sample statistic and calculate the P value. So because we're dealing with proportions, this is a one proportion z-test. Make sure you use the option on your calculator that says one prop z-test. Don't use the z-test option at the very top of the calculator. That's an option that typically we won't use. You want to use the option that says one proportion z-test. So I hope this has been helpful to make sure that you're on the right track. We will go over both of these two questions, the remainder of these questions, the conditions, the calculations, and the interpretation before we take our test. Good luck.